Hello, so in this video we'll start talking about planes. So let's start with the definition. Let's say we have P1 and P2, uh, some different point or distinct points. Then a collection of all the points P for which the vector P1, P2 is orthogonal to P1, P constitute a plane which we call as gamma here. Okay, so what we are trying to say is that we have a vector. Let's say this is my P1 and this is my P2. Okay, so then this, let's say this is this vector here, and this p1 is x1 x1 y1 z1. Then plane here, so for example this is the plane, and this is my point P, and this is my point P, and this is my p1 P here. Okay, so point P is general x y z. Okay, so this plane and this angle is actually 90 degrees. Okay, so this is in 3D, so that's why it looks a little bit you have to visualize a little bit. So what I'm trying to say is that all these points which are orthogonal to this vector, they form a plane. Okay, and this, since this vector is what, this vector is given by, so p1p is given by x minus x1, y minus y1, z minus z1. So all we are doing is the dot product of this vector to this vector should be equal to 0. So that's why we have the equation of the plane given by this expression. So this is very important to remember, that we have the normal vector given by the coefficients here, and a point is given by x1, y1 and z1. So this will form a equation of the plane. Okay, so let's start with doing some problems here. So now we are interested in plane through 3 points. So these are my 3 points. Okay, so then what I'm interested in is what? I have to find a vector PQ here, okay, and a vector PR here. So what, we have 2 points, so we can find 2 vectors. So find PQ and PR, or you can also find QR, it doesn't matter. Okay, and the next step is the orthogonal vector or normal vector will be what? If we have 2 vectors, how do we find the normal vector of both of them? We take the vector product, right? We have seen this before. So then this is PR. Now it doesn't matter if you choose QR, you will still be the right answer. Okay, so PQ, this is the cross product or the vector product. So let's write it like this, cross product. Okay, so this will give me the normal vector, and then you can choose either this point, or this point on the plane, and use that as x1, y1 and z1. So let's do this. So my PQ is what? PQ is minus 1 minus 3 is minus 4, 1 minus 2 is minus 1, and minus 2 minus 1 is minus 3. This is my PQ. What is my PR? PR is 3 minus 3, which is 0, minus 4 minus 2 is minus 6, 1 minus 1 is 0. Okay, now what is this guy? This guy, we use this thing, I, j, k, minus 4, minus 1, minus 3, 0, minus 6, 0. Okay, so then with I have what? These are all unit vectors. For I have 0, minus 18, so minus 18 here, and then j, what do I have here? So 0 minus 0, so this is 0, and for k I have what? I have 24 minus 0, so which is 24. So in this notation I can write it as minus 18, 0 and 24, correct? So this is my A1, A2 and A3. Okay, now I can choose, let's say Q I choose. So I can say minus 18 x plus 1 plus 0 y minus 1 plus 24 z plus 2, this is equal to 0. So I can, if we simplify it, we get minus 18x plus 24z plus 30 is equal to 0. Okay, so this is negative 18 here, and we have plus 48 here, so that's why we have. So this is the equation of the plane which passes through this. Now let's choose the point as P. So then we'll get minus 18 x minus 3 plus 0 y minus 2 plus 24 z minus 1. So then you will get minus 18x plus 24z, and then this is plus 54, this is minus 24, so we'll get plus 30. This is equal to 0. So you'll get, so it's always unique. So whether you choose P, Q or R, you will get the same equation of the plane. Okay, so this is one part. Now let's talk about the sketching the plane. Now let's see, let's say if we have the equation of the plane like this. Let's say we have 2x minus y plus 5z plus 10, this is equal to 0. Okay, and what we need is, now we are interested in this guy. So now we will, first of all, we will start introducing a concept of trace. So trace of a plane is where it touches either the xy plane or the xyz plane or xz plane. So trace on the xy plane is, so trace on the xy plane is formed when we put z is equal to 0. So then this means 2x minus y plus 10, this is equal to 0. So now on xy plane, what do we have? We have 2 points here. One is at 10, so then this is 0, 10, 0, and the other one is at negative 5. So the other one is at negative 5, because if you put y is equal to 0, you will get x is equal to negative 5. So negative 5 should be somewhere here. So here this point is minus 5, 0, 0. Is the trace of that plane along the xy plane. Similarly, we put y is equal to 0 and we get the trace of that line on the yz plane, xz plane. So we get 2x plus 5z plus 10, this is equal to 0. So this one, the x-intercept and the z-intercept. So the z-intercept is when we put x is equal to 0 and we get minus 2 here. So this is 0, 0, minus 2. And the x-intercept, the x-intercept is when we put z is equal to 0. So x is equal to negative 5 here. So then this is for xz plane. Okay, and if you put x is equal to 0, you will get minus y plus 5z plus 10, this is equal to 0, and you will get the exact same. So you will get, if you put y is equal to 0, you get z is equal to minus 2. If you put z is equal to 0, you get y is equal to 10. So then you have this as the trace of. Okay, so this is my plane. This is my plane of interest here. Okay. So this equation corresponds to this plane here. Okay. Okay. Now let's do another one. So now we have another equation. 4y minus 2z minus 15 is equal to 0. Okay, so for this one again, what we do, we okay, so for this one there's no x here. Okay, so what do we do if there is no x here? So this means we have only y and z, right? So all we can do is we can find the intercept on the yz plane only. Okay, so the yz, so for if you put z is equal to 0, you get y is equal to plus 15 over 4, which is, let's say, this one. So this is 0, 15 over 4 and 0. If you put y is equal to 0, you get negative 15 over 2. Let's say this is somewhere here. So 0, 0, negative 15 over 2. So this is the trace on the yz plane. Okay, now this one, this guy is actually what is the orthogonal vector here? So for the orthogonal vector we have 0, 4 and -2, correct? Because we know that the coefficients with x, y and z are our they constitute our orthogonal vector. So this means this is parallel to parallel to so this this vector is parallel to yz plane, correct? So this means the plane is orthogonal to yz plane, correct? So yz plane is this guy, so the plane should be orthogonal to that. Okay, so this means that the plane is goes like this. So then this is the actual plane, and the yz plane is this one, this yz plane, and this is the line. You can see that this is coming out of the page and this is on this y-axis, so that's why we can say this is orthogonal to this plane. Okay, so then this means this is the equation for this equation. This is the plane we get. Okay, so this is it about sketching a plane based on its equation, and also finding the equation of the plane if 3 points are given. Hope it was easy to understand, and thanks for watching. Hope you like the video.